Hello everyone, myself Ms. Vinita Janathan Raul, Assistant Professor in Mathematics from Ganpat Pasikar College of Education. I welcome you all for this course entitled Elementary Combinatorics. In that, we will be looking at first topic, that is basic methods, under which we will be covering 4 modules. In module 1, we will be looking at the basic pigeonhole principle. Now, as this name suggests, that is the basic pigeonhole principle, what will come to your mind is the pigeons and pigeonholes, right? So, the statement is very simple, that just in case if you want to know one example, let us say that there are 5 pigeons and there are only 4 pigeonholes. Okay? In that case, if all these pigeons want to occupy those pigeonholes, what will happen is that there will be at least one hole wherein you will find at least 2 pigeons, right? So this is the statement that we will see, but we won't be making use of the words pigeons and pigeonholes, but instead of the word pigeon, we will make use of the word ball, and instead of pigeonholes, we will make use of the word box. So let us look at the statement. The statement says that let n and k be 2 positive integers such that n is greater than k. Suppose we have to place n identical balls into k identical boxes where n is greater than k. So you see that the number of balls is greater than the number of identical boxes. Then there will be at least one box in which we place at least 2 balls. Okay? If you want to draw a picture to get a rough idea, this is how it looks. Suppose there are these k identical boxes. Let me name them as 1, 2 up to k. Okay? And in these boxes, since we are talking about n identical balls, we have to place them, okay, all n of them, but we will see that at least one box will be there wherein we will find at least 2 balls, and that is quite trivial because this n is strictly greater than k. Okay? Now, in order to prove this theorem, we will be taking help of the method of contradiction. So we will say that suppose there is no box in which we will find at least 2 balls. So in that case, what options are left with us are either there will be 0 ball or there will be maximum 1 ball in it. Okay? So proof by the method of contradiction. Suppose there is no box with at least 2 balls, then each of the k boxes has either 0 or 1 ball in it. Now let us denote by n the number of boxes that have 0 balls in them. Then certainly n will be greater than or equal to 0. Okay, so you will be able to find either 0 boxes wherein you will have 0 balls, or there can be 1 or more than 1 box wherein you will be able to find 0 balls. Okay, and we are denoting such boxes wherein we have 0 balls with this notation n. Now, total boxes that we have over here is k, and out of them n have 0 balls in it. Okay, so what is left with us is nothing but k minus n, and these k minus n boxes will have 1 ball in it because there are only 2 options with us, that is the 0 or 1. Then there are k minus m boxes that have 1 ball. So this will lead to a contradiction. How? So however, that would mean that the total number of balls placed into the k boxes is only k minus m, which is a contradiction because how many balls we have to place? Total n of them, n. This k minus m quantity is strictly less than k, and k in turn it is strictly less than n. So that means k less than n. Okay, so in this process what we have done is we have placed only k minus m balls, okay, which leads to contradiction. So if we are getting contradiction, that means our assumption is incorrect and there will be at least one box in which we place at least two balls. So therefore our assumption that there is no box with at least two balls is incorrect. Now with that, let us look at the first example. Let me read the example first. A chess tournament has n participants and any two players play one game against each other. Then it is true that in any given point of time there are two players who have finished the same number of games. Now if we see this example first, we may not get that idea that we can apply basic pigeonhole principle over here. Okay? And if we are applying the basic pigeonhole principle, that means we will require these values, that is value of n and value of k, wherein n refers to the number of balls and k refers to number of boxes. Okay? And the condition is that n has to be strictly greater than k. Yes, so the very first thing that we see over here is there are n participants. Okay, so we can treat this as your number of pigeons or number of balls in that reason. Okay, and we have to show that there are two players who have finished the same number of games at a given point of time. So in this case, then we have to find this k. Now over here we are looking at the number of games, isn't it? So if this n refers to that number of balls, that number of boxes will refer to the number of games played at a given point of time. So let us write down. We have n players or n participants. Then, now if we consider one single player, maximum how many games that particular person can play. Okay? Now since there are n participants, maximum games that any player can play will be n minus 1. So how many options do we get over here? Either a person can play 0 games, 1 game, 2 games or up to n minus 1 games. So number of games finished can be any one value among this elements 0, 1, 2 up to n minus 1. Now if you count these numbers, how many do we get? We get total n of them. But if you want to apply this pigeonhole principle, then we won't be able to apply that principle in this case if number of participants will be equal to number of games. But if you notice one thing, that if at all one participant has played n minus 1 games, that means what? That player has played with rest all of the participants. That means you won't be able to find any player who has played 0 number of games. So this tells us that this 0 and n minus 1 cannot occur together. So in that case we discard this value and total options that we get for the number of games will be either 1, 2 or up to n minus 1. So here we get these n minus 1 options. Now we can apply the pigeonhole principle. Okay. So let us write down that in a form picture. So these boxes are nothing but the number of games played. So we can have 1, 2 up to n minus 1. So now there are n minus 1 boxes and there are n balls or n participants. So by basic pigeonhole principle, it tells us that there will be at least one box which will have at least two players. Okay, let's say suppose these two players lie over here. So it tells us that there are two players who lie in this particular box. So that means there are two players who have played same number of games, that is nothing but the value 2. Okay. Okay, so with that we prove the statement, that is in any given point of time there are two players who have finished the same number of games. So therefore there are two players who have finished the same number of games. Let us look at one more example which has got mathematical nature. Suppose a1, a2 up to an are integers, then some consecutive sum ak plus 1 plus ak plus 2 up to ak plus n is divisible by n. Again, for this example, we are going to apply the basic pigeonhole principle. If you see over here, there are total n integers. So this n integers, they refer to your n pigeons in the statement. What we have to find is what is the value of k, that is number of boxes. For that, let us consider the sums. We are talking about the sums of these integers a1, a2 up to an. So let S1 denote the sum a1, that is it has only one value. S2 denote the sum of first two integers, that is a1 plus a2. And this continues, let Sn denote the sum of the n integers, that is a1 plus a2 up to an. Now in case this sum, any of the sums, they are divisible by n, we are done. That is what we wanted to prove, that some consecutive sum is divisible by n. So if in case any of the sum is divisible by n, what do you mean by being divisible by n? Is that the remainder has to be 0. So if the remainder is 0, then our statement is proved. If not, then we have to apply your pigeonhole principle. So if one of them is divisible by n, then we are done. Okay? If not, which means that none of these sums they are divisible by n. So when we divide this S1, S2 or Sn by n, the possible remainders that we get can be 1, 2 up to n minus 1. Okay? We cannot get 0 because they are not divisible by n. So if not, that means Sn's are first of all not divisible by n. Then the possible remainders are 1, 2 up to n minus 1. So now we get it. Here we are getting this set of remainders, and how many are there? There are n minus 1 of them. We can treat this n minus 1 remainders as our boxes. So we have n integers and there are n minus 1 boxes. So 1, 2 up to n minus So here you will put down those numbers whose remainder is 1 when you divide by n. Here you will put those numbers which when divided by n gives you remainder 2 and so on. So since there are n minus 1 boxes and n integers by basic pigeonhole principle, there will be at least one box which has got at least 2 integers. Therefore, by basic pigeonhole principle, there is at least one box which has at least 2 integers. Okay, integers or we are referring in this case not the integers but the sums. Okay, there are total n sums. So this is not a correct word to make use of. We are talking about this n sums over here. Okay, I'm sorry for that. It is n sums. So if this S1 gives a remainder 1 after dividing by n, it will be put over here. S2 if it has got remainder again 1 after dividing by n, then it will be put over here and so on. Okay, so we are not putting integers, we are putting these sums S1, S2 and up to Sn. So these are your pigeons in that case. Okay, so which has at least 2 sums. So that means we'll be able to find 2 sums over here which has got same remainder, and let us denote those sums with Si and Sj. So that is, there are 2 sums, say Si and Sj, having same remainder. Let us say I is less than J. So what will be Si? Si will be A1 plus A2 up to Ai. Sj will be A1 plus A2 up to Aj. And since I is less than J, this Sj will have more terms than Si. Now when we subtract these 2 numbers or 2 sums, Si minus Sj or Sj minus Si, so therefore Sj minus Si. Okay, when we subtract these 2 numbers, since the remainder is same for both of the sums, the difference will be divisible by n. So this is divisible by n, because in that case the remainder will be 0. Now this is also a sum, Sj minus Si, because both were sums, and maybe we have, say, Sj minus Si is equal to, now up to that ith component all the terms will go off, and what we will be left with is Ai plus 1 plus Ai plus 2 up to Ai plus J. So we have got such a sum which is divisible by n in this case, and hence we are done with this example, that is some consecutive sum ak up to ak plus n is divisible by n. And this we could prove by making use of your pigeonhole principle. This is the reference book that I followed, Miklos Bona, A Walk Through Combinatorics.